Hello students, നമ്മൾ ഇതിനോട് റിലേറ്റഡ് ആയിട്ടുള്ള ഒരു ഇമ്പോർട്ടൻറ്റ് റിസൾട്ട് സ്റ്റേറ്റ് ചെയ്ത് പ്രൂവ് ചെയ്യാം. സോ ഐ വിൽ റൈറ്റ് ദിസ് ആസ് എ തിയറം. പാത്ത് ഇൻഡിപെൻഡൻസിനോട് റിലേറ്റഡ് ആയിട്ടുള്ളതാണ്. The following are equivalent. The following are equivalent. I will write it TFAE for the following are equivalent. 1. Integral f dot dr is equal to 0. Integral f dot dr is equal to 0 for every closed loop integral over C. For every closed loop C lying in the domain D of f. 2. F is conservative. So what is the meaning of that? That is line integral is path independent. That is line integral f dot dr is path independent. That is what is meant by conservative. So this line integral depends only on the initial points A and B, initial and final points A and B, not the in between points of that path. That is value of the integral depends on integral depends only on the initial point A and final point B of the path not the in between points of the path. So all these are explanations what is meant by conservative. I have told what is meant by conservative, but if you don't remember, then this is the definition. Conservative means path independent. What is path independent? Value of the line integral depends only on the initial and final points, not the other points of the path. Okay, so we shall prove this. The proof is so easy. So what is meant by the following are equivalent? It does not mean that both 1 and 2 hold. The thing is that if 1 holds, then 2 also hold. And conversely, if 2 holds, then 1 also should hold. അപ്പോൾ 1 ഹോൾഡ് ചെയ്യില്ല എന്നുണ്ടെങ്കിൽ 2 ഹോൾഡ് ചെയ്യില്ല. 1 ട്രൂ ആണെങ്കിൽ 2 ട്രൂ ആണ്, അതുപോലെ 2 ട്രൂ ആണെങ്കിൽ 1 ട്രൂ ആണ്. അതുകൊണ്ട് 1 ട്രൂ ആവണമെന്നില്ല. ഓക്കെ, സോ സപ്പോസ് 1 ഹോൾഡ്സ്, I have to show 2 also hold. So what is 1? Assume integral f dot dr equal to 0 for every closed curve C in D. Lying in the domain d of f. So I am assuming 1. I have to prove 2. So take any 2 points a and b. So I am in the space x-axis, y-axis, z-axis. This is the point A, this is the point B. So I have to prove that integral from A to B depends only on the points A and B, not the in-between points. So I can choose this path. So my path is, let us say, C1. You can choose another path. This is your path, C2. Okay. So to show 2. That means path independent. That is to show integral over C1. I am integrating over C1. My path is C1. F dot dr equal to, and you are integrating over C2. Your path is C2. Integrate over C2 f dot dr. This is what you have to prove. Okay. Our assumption is over every closed curve integral f dot dr is equal to 0. But my curve C1 is not closed. Your curve C2 is not closed. But the thing is, can you find a closed curve in this figure? Yes. You start with A, travel along C1, reach B, and travel in the opposite direction along C2. You will reach again the point A. So this is a closed curve. This is a closed curve. So how do I express that closed curve? I will express that closed curve as C1 minus C2. What is minus C2? Minus C2 is the opposite curve of C2. C1 minus C2. So observe, C1 minus C2 is a closed curve lying in the domain. Closed curve lying in D. Now we use 1. By 1 or by assumption, integral over C1 minus C2 f dot dr must be equal to 0. But integrals have the additivity property. What is additivity property? Line integrals. If I have a curve like this is my C1 and another curve, this is my C2, then you look at C is equal to C1 union C2, or another notation is C1 plus C2. C1 plus C2. Then integral over C is the same as integral over C1 plus integral over C2. This is called additivity property of line integrals. For that, you need the end point of C1 must be the same as the initial point of C2. The end point of C1 is this, and the initial point of C2 is again this. So in this case, additivity property holds. So let us use that additivity property in the previous integral. So this implies that integral over C1, integral over C1 minus C2 is integral over C1 f dot dr plus integral over minus C2 f dot dr. This is your integral over C1 minus C2. Okay? And C1 minus C2, that is a closed curve, so integral equal to 0. So the left side, this is precisely 0. So what I got? Now one more thing, integral over minus C2. You can prove that that value is the same as over minus C2 is minus integral over C2. You have this property also. This is another property of line integrals. Like additivity property, you have this property. So let me substitute the value of integral over minus C2 as minus integral over C2. So what I will get? 0 is equal to integral over C1 f dot dr minus integral over C2 f dot dr. Okay, because integral over minus C2 is minus integral over C2. This implies integral over C1 f dot dr is the same as integral over C2 f dot dr. So this is precisely path independence or the statement 2. So 1 implies 2 we have proved. 1 implies 2 we have proved. Now the other way around. Assume 2. Assume 2. I have to prove 1. Conversely, assume 2. So I am proving 2 implies 1. Proof of 2 implies 1. So assume 2 means integral over every closed curve equal to 0. What I have to show? Oh, sorry. What is 2? F is path independent. Work done is path independent. I have to show integral over every closed curve equal to 0. That is to prove integral over a very closed curve equal to 0. So take a closed curve. So let C be a closed curve lying in D. Let C be a closed curve in D, which is the domain of F. Let A and B be any 2 points, distinct points. Lying in C. So let us say this is A and this is B. Okay. Call this portion that as your C1 and B to A. B to A. This portion that is your C2. So C is precisely C1 plus C2. So integral over C f dot dr is integral over C1 f dot dr plus integral over C2 f dot dr so C2 I cannot make this way, I have to make the other way around. That means starting from A and ending at B. So just a second. So C2 is the curve starting at A and ending at B. So both C1 and C2, they are curves with the starting point A and the ending point B. So integral over C1 f dot dr is so what is our assumption? 2. It is path independent. So this is integral A to B f dot dr. It depends only on the initial and final points. F dot dr plus integral over C2, that is also A to B f dot dr. Oh, it's a small mistake. The earlier choice of C2 was right. C2 I am choosing with the initial point B and final point A. See, we should make mistakes, then only we learn. So C2 is this curve starting at B and ending at A. So what is integral over C2 f dot dr? It is B to A, right? So integral over C f dot dr. C is a closed curve, and I have to show this is equal to 0. What is our assumption? We are assuming 2. That means f is path independent. So this is equal to integral A to B f dot dr minus integral B to A f dot dr is minus integral A to B f dot dr so this is equal to 0, and this is what we wanted to prove. So integral over every closed curve is equal to 0. Hope you understood the proof. Thank you.